Hello, this is the Math 159 Gould Chapter 1 Section 5 video on causality. So, when I talk about causality, I mean, does one thing cause something else? So, how do we figure out if X causes Y? And this could be all sorts of things, like for instance, COVID-19 has been a thing, and we can ask ourselves a question such as, does the vaccine cause someone who catches COVID-19 to have a less severe case? All right, so how do you actually show that the vaccines are effective? Ultimately, when we're talking about something being effective, we're saying that it causes a particular sort of response. Okay, so this is a big important question in statistics. Because there's a lot of things where we want to know if it actually works. Like, is there a point in taking the vaccine? Is there a point in giving everyone the vaccine? It all costs money. Okay, so interestingly enough, how the data is collected determines if we can conclude that there's causality versus association. Okay, so let me explain the difference between those two. So causality means that X causes Y. So I'm going to put a little arrow like that. One causes the other. Association doesn't mean that X causes Y, but that X and Y occur together often. So association is a weaker sort of statement. We're saying, look, we just happened to notice that when people take the vaccine, they usually don't get as sick. Now, there could be another reason for this, so we're not saying that there's causality yet. So when you want to determine whether something causes something else, or whether the two things are simply associated, how the data is collected is going to be the big distinguishing thing between this. Okay, so for causality, we're going to deal with what are called experiments. So you need to collect your data in such a way that it can be called an experiment to determine causality. Association, on the other hand, that's anecdotal evidence. Or something more strong would be something called an observational study. Okay, so the way that your data is collected will determine whether your data was collected anecdotally, it was collected in an observational study, or it was collected in an experiment. So the ones in blue can only allow you to determine that there's an association, whereas the one in green allows you to determine causality. Okay, so we want to talk about X causing Y. Usually we put X arrow Y. And whatever X is, we usually call that the treatment. So people get a treatment, and we want to see if this treatment causes a particular response or outcome. Okay, so this is just some terminology. So the thing that you're looking to see whether it happens or not, we call that the response or outcome variable. And then the thing that you think causes the outcome or affects the outcome, you call the treatment variable. Okay. So as an example, does smoking cause cancer? Interestingly enough, a lot of the statistics behind this was determined because for the longest time people pointed out, and you'll see why, that it's actually rather difficult to determine that smoking causes cancer. Sort of like saying, I guess, that emissions cause global warming. Right? We have a good theory as to how it works, and it's probably correct. And there's a good theory as to why smoking causes cancer, but you'll see in a little bit. Okay, cool. So, let's talk about an experiment. Or, no. So, you know how when we're dealing with people, we call them the subjects? So the subjects are either in the treatment or the control group. Okay, so let's talk about determining if smoking causes cancer. So smoking is the treatment. So any subject who smokes would be said to be in the treatment group. Now, the control group are the people who do not get the treatment. So if you're determining whether smoking causes cancer, smoking is your treatment variable. Anyone who smokes would be in the treatment group. Anyone who doesn't smoke would be in the control group. So there's two groups, the people who get the treatment and the people who don't get the treatment. And you might be wondering, like, well, why do you need the two of them? It's because you need to compare the groups. You need to make a comparison. If you want to show that smoking causes cancer, the people who smoke should have more cancer than the people who don't smoke. So you need to have two groups, the treatment group, the people who smoke, the control group, the people who don't smoke, and then you can compare them. Because if you only look at people who smoke, you can't actually say that smoking seems to cause anything. So to be able to see if something causes something else, you need to be able to make a comparison. Now, so yeah, you need to be able to make a comparison. So now let's talk about anecdotes, because I talked about anecdotal data. So anecdotal data is the weakest sort of data that you can get, and it just means that, like, you seem to notice something where there's no comparison. So if you ever collect data just about smokers and you happen to notice that a lot of them seem to have cancer, that's just anecdotal data, because you don't know what the rate of cancer is for people who don't smoke. What if there is no difference? What if you looked at smokers and then you looked at non-smokers and they both have the same levels of cancer? Okay, so anecdotal data would be something like, hey, I noticed my hair was thicker if I took vitamin C tablets. You just happen to notice something. To really get some data as to whether vitamin C seems to give you thicker hair, you need to give a bunch of people vitamin C and then also look at a bunch of people who don't take vitamin C and compare the groups. Okay, this is important because there's something called a placebo effect. So a placebo is when the people in the treatment and the control can't tell the difference as to which one they're in. So subjects can't tell if they're in treatment or control group. So let's say you're testing a medicine. If you show up and you know you're in the treatment group because you get a pill, and they put you in the control group and they don't give you a pill, then you know that you're not getting the medicine. And actually, if you think you're getting medicine, actually usually affects how you feel. So let's say that let's say we're treating the effectiveness of pain medication. If I give you a pill and say it's pain medication, interestingly enough, you're more likely to say, oh yeah, my pain has gone away, even if the pill is fake. So fake pills, we call those placebos. So you give people placebos so they don't know if they're in the treatment or the control group, because thinking that you got medicine actually usually affects how you will, like, rate your pain and such. Okay, so anecdotal data is just when you have no comparison group, and if you want to be able to say compare, like, if you want to be able to test the effectiveness of medicine, you need to give people fake medicine so they can't tell which group they're in, and so you'll have the two groups to compare. Okay, so let's talk about observational studies now. Okay, an observational study is when the subjects place themselves into the treatment/control groups. And with an observational study, you can only conclude association. Okay. So an observational study is when you do have two different groups. There are people who get the treatment and there are people who don't get the treatment. But how they got into those groups was determined by the subjects themselves. And this is why actually it's hard to show that smoking causes cancer, because people choose to smoke or not, right? So they place themselves to the treatment or the control group, either smoking or not smoking. And I won't explain why, but basically when subjects place themselves like this, you can't say that the treatment variable causes the outcome variable. You can only conclude that they're associated. So you could say, hey, I've looked at these two groups, I've compared them, and the people who smoke seem to have more cancer. So smoking seems to be associated with getting cancer. Why is this? It's because there could be something called a confounding variable that causes both. Maybe there is some single cause that causes people to want to smoke and to get them to have cancer. And actually, for decades, this is what scientists thought might be the case. There were several famous statisticians who argued that, well, there could be a confounding variable, and their idea was that maybe it's genetics. Maybe people who are genetically prone to getting cancer are also genetically prone to enjoying smoking. And maybe that's why you see the two associated or occurring together. Okay. And you might be wondering, well, why is it that placing yourselves into treatment or control groups only allows you to conclude association? Well, there could be a confounding variable that causes both. So to rule out the possibility of a confounding variable, you need the treatment and control groups to be similar. So for instance, what you could do is if you think that the cause, the confounding factor, is that there are genes that make people want to smoke and make them get cancer, you could then do a genetic analysis to make sure that there seemed to be a similar distribution of genes between the treatment and control groups. So you could rule out the possibility of the confounding variable by making sure the treatment and control groups are similar. So if you think the confounding variable is genetics, you could first do a genetic analysis of the two groups and make sure they seem similar. Okay, this is called controlling. Making the groups as similar as possible is called controlling for a confounding variable. Okay, so one of the best ways to control for a confounding variable is just an experiment. So what is an experiment? An experiment is when the researchers place the subjects into treatment and control groups. Why do the researchers place them into treatment and control groups? To control for confounding variables. So the idea is well, if you want to be able to show that X causes Y, place the subjects into treatment and control groups yourself. Make sure that these two groups are really similar so that we rule out the possibility of a confounding variable, and then you can actually conclude causality. Conclude if X causes Y. So in an experiment, you can conclude if X causes Y. And this is possible because the researchers place the subjects into the treatment and control groups themselves, and that controls for confounding variables. Now, all good experiments have several things in common, and I want to go over those, the properties of good experiments. So good experiments have a large sample size. So remember, the sample is all the different subjects that you're dealing with. The more people that you're studying, the better your results are likely to be. Or the more, not better the results are likely to be, the more trust you can have in your results. Okay, now this is very important. You must place the subjects randomly into groups, the treatment and control groups. We call this random assignment. So the researchers are not going to themselves decide which subjects go into the treatment and control groups. They're actually going to randomly place them. And there's actually good reasons for this. If the researchers use some sort of criteria to place people into the groups, your experiment will be biased because there was some sort of criteria they used. So the best way to make sure that your groups are basically the same is to randomly create your groups. And this avoids bias. Okay, your experiment should be double blind. Okay, double blind means that neither the researcher nor the subjects know which group they're in. And this is actually really important because remember what I was saying earlier, if I give you medicine, pain medicine, you're more likely to say that you don't feel pain. So the person who's receiving the medicine, they shouldn't know if the thing they're getting is the medicine or the placebo. Also, more importantly, the person who gives you the medicine shouldn't know whether it's the real medicine or the placebo, because there are subtle effects. Like, if I know that I'm giving you the placebo, subconsciously I might be signaling to you somehow that it doesn't really matter, and people actually sort of pick up on these things, and like subconsciously I didn't actually get the medicine, and so you don't feel the effect of it. It's actually really interesting how this works. They've done a lot of research on this. People knowing if they're getting the real thing or not affects how they feel. Okay, and then you should have a control group, if possible. Sometimes it's not possible to have a control group, usually for ethical reasons. So for instance, let's go back to whether smoking causes cancer. So if you want to determine if smoking causes cancer, you need to do an experiment, which means I need to decide if people are going to smoke or not. That's not ethical, right? I doubt you're going to get people to sign up for an experiment in which, for the next couple years, I decide whether you smoke or not. So sometimes it's just simply not possible to have a control group. Okay. So, if you run an experiment where you randomly place people into treatment or control groups, you can conclude whether X causes Y. If, however, if the subjects themselves place them into groups, that's an observational study, and you can only conclude that there's association. Okay, finally, at the end of the observational study or experiment, you can analyze the results and make a conclusion about the sample. So for instance, like you get your group of 10,000 people, 5,000 of them smoke, 5,000 of them don't smoke, and you notice that at the end of it, the people in the smoking group are way more likely to have cancer. So that means the people that you studied, in the group of people that you studied, it appears that smoking is associated with cancer. Now, that's a statement about the group of people that you studied, or the sample. We want to generalize our results from the sample to the population. Okay, so whenever you do a study or an experiment, you can look at the results from that small group of people and say, hey, look, this is what I observed in this group of people. That's actually not very useful. You want to generalize what you saw in your sample to the population. And there are some criteria about when you can do this. So when can you generalize from the sample to the population? Only if your sample, the people that you studied, reflects or is similar to the population. So if you do an experiment and the group of people that you do the experiment on do not look like the people that you want to generalize about, you are not going to be able to. And this is actually a big issue in psychology. Most psychological research is done on undergraduate students in college. And only about 30% of the population ends up getting an undergraduate degree. So if your psychology experiment is all done on undergraduates, and that's a small group of your population, you're not going to be able to generalize those results. Okay, and this is the end of the 1-5.